Hello everybody, how's it going? My name is Eric. So today we are about to talk about this integral, which is related to Riemann sum as well as the floor function. So let's look at the integral first. So in this question, we need to first let I equals to the integral from 0 to n squared. And we copy this first. And then we need to first deal with the floor function here, which is the floor function of the square root of x. So in order to simplify this, we can first let u equals to the square root of x, so that x equals to u squared and dx is equal to 2u times du. And then in this way, we can give I equals to integrate from 0 to n, and the inner side is the floor function of u and over u squared times 2 times u. And we do this in order to simplify the square root of x. And in this way, we can consider the floor function of u. So let's consider this. So in terms of the floor function of u, for u from 0 to 1, we can see all the values of the floor function of u equals to 0, right? So similarly, we can get like this. So I think because this is discrete, we can transfer this into the summation from k equals to 0 to n minus 1, and integrate from k to k plus 1. And then let's copy this. So here we can see the floor function of u turns into k. This is because if we so this term is actually equivalent to consecutive integral from 0 to n, right? And apart from this, we can see that if it is from this is k and this is k plus 1, then actually for all values from k to k plus 1, the floor function of u actually also equals to k, right? So in this way, we can just consider it to be k and copy this. So in this way, we can eliminate the value of u and take 2 out of the summation, like this one. And then this is also integrate from k to k plus 1. And the inner side is actually n squared minus k squared and du. So because this is considered as a constant, as it is integrated with respect to u, so actually the value of this integral is just the square root of n squared minus k squared. And lastly, let's substitute this value into this. So we let L equals to the limit of that. So L is actually equals to limit n tends to infinity 2 over n squared times k equals to 0 to n minus 1 and the square root of n squared minus k squared. So our next step is to substitute one of the value of n into this summation. Then we'll get limit as n tends to infinity 2 over n, and the summation is k equals to 0 to n minus 1, and the inner side is 1 minus k over n, so square. And we do this because we want to construct the form like this one. That is, if we have limit as n tends to infinity 1 over n times sigma k equals to 0 to n f of k over n, this is called Riemann sum. So Riemann sum is equal to the integral from 0 to 1 f of t dt. And then we just need to change the variable of k over n into t. So that is 2 times integrate from 0 to 1, and the inner side is actually the square root of 1 minus t squared dt. So in order to integrate this, we can first consider the equation of the circle, which is x squared plus y squared is equal to 1. So the graph of this is like this with radius 1, right? And if we replace y by t, and we'll get x is equal to the square root of 1 minus t squared, right? And we know that in this question, t is from 0 to 1, so it is actually needed to be considered the positive side. And also the square root of this is positive, so we only need to consider both of them to be positive. So we just need to consider 1 over 4 of the total area of the circle. That is 1 over 4 times pi times 1 squared, which is pi over 4. So in this way, we calculated the area of this, which is the integral of this one, which is 2 times pi over 4, which is pi over 2. Then we successfully deal with this question with just the Riemann sum as well as the integral.